Thomas Ken, former NASA technology director, shared his mind on the launch of the James Webb Space Telescope, marking the start of a brand new technology in astronomy. Webb is poised to expand and take a look at our cosmology and our understanding of planets and the beginning of life. What started with a bit of luck was a debacle. James Webb has taken aback scientists with a disaster. Will the disaster now worsen? Or will a brand new discovery of the James Webb Telescope end the controversy in physics? The discussions of approximately vintage theories and who is proper or wrong come to a temporary end. But what precisely does this suggest? Have scientists without a doubt unraveled the mystery surrounding James Webb's not possible discoveries? Or are we just being stalled with flimsy motives? James Webb became speculated to convey solutions, but instead, the $11 billion assignment plunged cosmology into a major disaster. All parts of natural technology associated with space are currently experiencing a shakeup of the type we last saw within the Middle Ages with the shift to the heliocentric view of the world. Now we can also have to recognize that the principles of our modern physics also are mistaken and that we've not come close to understanding what our cosmos sincerely is. However, how is this possible? Modern astrophysics, or in other phrases, the science of the bodily quantities and relationships in the cosmos, is based on the basic guidelines of physics, which basically go lower back to researchers of antiquity, the Middle Ages, and in particular to Sir Isaac Newton. The primary observations of mechanics and dynamics had been made in antiquity. Quantities and forces have been described for the first time, and later Newton located gravity, which is so essential for astrophysics. We constructed our scientific observation of the universe on these foundations. We transferred the quantities and forces that have been legitimate and observable on this planet to the universe, and this produced some consistent results. But then the gap we can see got larger and larger, and at a certain point our recognized quantities did not fit to describe what we see. This crisis started with the trouble that specific methods of measuring the age and expansion rate of the universe led to contradictory results. Local measurements primarily based on astronomical objects within the universe gave different values than measurements of the early universe based on the cosmic microwave history radiation. We realize this dissonance because the Hubble voltage. While the Hubble constant indicates the expansion rate of the universe inside the summer season of 2022, Webb determines so many vintage and noticeably advanced galaxies in space that doubts arose as to how the age of the IE turned into decided. Our cosmos can hardly be 13.8 billion years vintage if, thanks to Webb, we see galaxies that were already well developed 200 to 300 million years after the Big Bang. According to the calculations of our physics, galaxies need billions of years to develop. In the case of the galaxies determined via Webb, this will even imply that the time of their formation became earlier than the Big Bang. Our vintage cosmology, in keeping with which the universe began with a large bang 13.8 billion years ago, has been expanding ever in view that and has gone through a gradual manner of evolution of be counted. Cannot be correct. We're at a crossroads. Either we are making a mistake if we assume that our earthly physics may be applied to the whole universe, or we have up to now most effective deciphered a small part of the physics that exist within the cosmos. Webb breaks all statistics. It is remarkable. This telescope can pick up extremely weak light of alerts. Webb's 18 honeycomb-shaped mirrors effortlessly come across mild that has traveled through space and time for extra than 13 billion years. A special exposure technique makes these faint places of mild visible for the first time. Thanks to the brand new modern technology, we saw the light from the most distant galaxies that formed shortly after the Big Bang for the primary time in the summertime of 2022. Those galaxies were a sensation and at the same time a bitter disappointment. As opposed to baby galaxies, Webb shows perfectly advanced galaxies that seem to be several billion years antique. But with an age of 13.5 or 13.6 billion years, this could in no way be the case. In recent times, scientists once in a while say that the objects and the photos are not impossible or not real, but Webb can handiest show us the reality. Technology ought to now admit that it has probably been on the wrong song for greater than a century. That is roughly how antique our preferred cosmological model is. What we see right here is real. Webb works flawlessly. It's just that huge components of our technology are nonetheless unable to come to terms with the new truths. Some of the vintage traditionalists who do not want to appearance the new truths within the face vehemently oppose the end of the Big Bang or the idea of expansion. Within the Middle Ages, It additionally took a few years before the Church was ultimately willing to admit that the Earth turned into now not the center of the universe, despite the fact that there were all of a sudden hundreds of evidence from astronomers all over Europe. So not much appears to have changed, and despite the fact that we recall ourselves a great deal greater contemporary nowadays, we have a similar state of affairs. Researchers who proclaim something new may also now not come to be in prison like Galileo. However, the quarrels between researchers and the hostility toward new matters are nonetheless there. Consider you have spent a lifetime discovering and firmly believing in something, and then you spot snapshots or any other aspect of truth that inform a distinctive tale. Perhaps your thoughts would also revolt against this before everything, and it would take a while before you could be given the new fact. As everywhere, there are some who are faster to adapt and others who take longer. Many open-minded and younger scientists are obsessed with Webb's discovery. Rohan Naidu, the discoverer of the galaxy Z13, and S.F.L. Stein, who located MA Galaxy, belong to this open-minded generation of researchers. They study Webb's photographs with an open mind and have been studying them since the first moment of e-book. Each astronomer emphasized several instances in interviews that we cannot understand what will take place in astrophysics. At this moment, we should wait for further dimension outcomes, research, and of course, Webb's contemporary pictures. Was it Hubble's fault? Let's have a look at the quandary. One of the exceptional debates in current cosmology issues the Hubble steady, that is the price at which the universe is supposedly increasing. In the 1920s, astronomer Edwin Hubble observed that distant galaxies were shifting far away from us. From this, he concluded that the universe is expanding. The idea was later accelerated upon, and the Belgian astronomer Lemaitre postulated that this growth originated from a single factor, the Big Bang. These days, we already recognize from opportunity strategies that the motion of galaxies also can be defined differently. And these procedures also offer a coherent image of their entirety. However, they have been left out for a long term because the old theories had been considered more probably. However, the more we see of the universe, the extra discrepancies emerge. This didn't simply begin with Webb. Even 2 decades in the past, there were areas in space where the growth was behaving otherwise. It becomes as though these regions were once in a while faster and once in a while slower or perhaps denser or emptier. This caused speculation that there may additionally have been several starting factors or that our universe is even permanently fed via numerous assets, which do now not necessarily all must have had a beginning at the identical time or in any respect. Alternative thoughts approximately the shape, nature, and age of the universe emerged once more. However, researchers continued to cling to the antique theories of the Big Bang and enlargement. This turned into probably a mistake. We have already in brief found out about the Hubble tension. In brief, it shows clear differences in distance measurements in the universe depending on which fixed factors we use as size constants. Now, scientists hope that the Webb telescope, as its challenge progresses, might be capable of clearing up this tension by making unique measurements of the distances and purple shifts of galaxies. The potential correction of mistakes in previous dimension methods no longer simplest represents an essential turning point, however, also holds the promise of ushering in a transformative paradigm shift, propelling us into a new generation of advanced physics that penetrates the very material of cosmic fact. This monumental achievement stands as a testament to the unwavering willpower and tireless perseverance of generations of researchers who've devoted their lives to unraveling the enigmatic mysteries of the universe, tirelessly pushing the barriers of human knowledge ever further in their quest for fact and understanding. In their relentless pursuit of understanding, these intrepid explorers have now not most effective improved the horizons of our expertise of the cosmos, but have additionally enriched our collective cognizance, igniting an experience of wonder and awe on the vastness and intricacy of the cosmos that surrounds us. As we stand on the precipice of this new frontier, poised on the brink of discovery, it is incumbent upon us to technique every new revelation with open minds and open hearts, embracing the potential of even the maximum strange or stunning findings to reshape our understanding of the universe in profound and surprising methods. Indeed, the emergence of recent theories and alternative motives heralds the dawn of a brand new technology in scientific inquiry, wherein entrenched paradigms are challenged, and bold new thoughts beckon us forward into uncharted territories of understanding and exploration. At this pivotal juncture in history, we find ourselves at the cusp of a profound scientific revolution in which the investigation of the oldest factors of light inside the universe holds the tantalizing promise of unlocking the innermost truths approximately the character of existence itself. With the arrival of cutting-edge technology, which includes the James Webb Space Telescope, we are poised to embark on an extraordinary adventure of discovery, delving ever deeper into the cosmic tapestry to resolve the mysteries of accretion disks, probe the enigmatic realms of supermassive black holes, and peel back the layers of cosmic phenomena that shape the very fabric of our universe. But as we chart this path into the unknown, it is imperative that we remain ever vigilant toward the siren call of complacency, steadfastly resisting the temptation to succumb to the comforting appeal of familiar motives and old paradigms. Rather, let us boldly embrace the spirit of scientific inquiry, cultivating a mindset of relentless curiosity and intellectual openness that empowers us to question, to challenge, and to explore with unyielding dedication. In doing so, we honor the legacy of those who came before us, building upon their pioneering efforts as we strive to unlock the secrets of the cosmos and illuminate the boundless wonders that await us beyond the horizon of our current understanding. The universe is in a problematic symphony of forces and phenomena, each contributing to the grand tapestry of existence in ways that we are only beginning to realize. As we embark on this journey of discovery, let us do so with a sense of humility and marvel, ever mindful of the profound mysteries that lie beyond our grasp and the boundless potential for new understanding that awaits us in the vast expanse of the cosmos. In the words of the great astronomer Carl Sagan, somewhere, something incredible is waiting to be discovered. It is our shared mission to seek out that extraordinary something, to push the boundaries of human knowledge, and to embrace the unknown with the courage and curiosity that define the very essence of scientific exploration. With the advent of cutting-edge technology such as the James Webb Space Telescope, JWST, humanity stands on the threshold of a new era in astronomical exploration. Webb, with its unprecedented capabilities and sensitivity, promises to revolutionize our understanding of the cosmos in ways previously unimaginable. Its 18 honeycomb-shaped mirrors, designed to capture extremely faint light that has traveled across billions of years, offer a glimpse into the earliest epochs of the universe's formation. Webb's ability to observe distant galaxies and capture their light in exquisite detail has already begun to challenge and reshape our existing cosmological models. One of the key revelations brought forth by Webb's observations is the discovery of galaxies that appear far more developed than expected at such early cosmic times. These observations suggest that some galaxies may have formed and evolved more quickly than previously thought possible, potentially calling into question our understanding of galactic evolution and the timeline of cosmic history. The implications of these findings extend beyond astrophysics and cosmology into fundamental physics itself. For decades, our understanding of the universe has been shaped by theories like the Big Bang and the expanding universe model, which have provided a framework for explaining the large-scale structure and evolution of the cosmos. However, as Webb continues to peer deeper into space and time, discrepancies and anomalies in our observations challenge these established paradigms. One of the long-standing debates in cosmology revolves around the Hubble constant, which measures the rate at which the universe is expanding. Edwin Hubble's discovery in the 1920s that galaxies are moving away from each other provided the first observational evidence for cosmic expansion. Subsequent refinements and observations, including those from the Hubble Space Telescope and now from Webb, have attempted to measure this expansion rate more precisely. However, recent measurements from Webb have introduced new complexities. Different methods of measuring distances and redshifts of galaxies yield conflicting results, creating what is known as the Hubble tension. Local measurements based on astronomical objects within our nearby universe suggest a different expansion rate compared to measurements derived from the cosmic microwave background radiation, which provides a snapshot of the universe's early history. This discrepancy challenges our current cosmological models, raising questions about the nature of dark energy, the hypothetical force responsible for the accelerating expansion of the universe. Some theorists propose that new physics beyond the standard model may be required to reconcile these conflicting measurements, suggesting the potential for a paradigm shift in our understanding of fundamental forces and the nature of the universe itself. Beyond its implications for theoretical physics, Webb's observations have practical implications for future astronomical research and space exploration. By studying the light from distant galaxies and the early universe, Webb allows astronomers to peer back in time to understand how galaxies formed and evolved over billions of years. These observations provide valuable insights into the conditions that led to the emergence of stars, planets, and ultimately life itself. Webb's advanced instruments and observational capabilities also pave the way for studying exoplanets, planets orbiting stars beyond our solar system. Detecting and characterizing exoplanets, particularly those within the habitable zone where conditions might support life, is a primary goal of Webb's mission. By analyzing the atmospheres of these distant worlds, scientists hope to identify signs of habitability or even potential signatures of life. Moreover, Webb's observations contribute to our understanding of other cosmic phenomena, such as black holes, neutron stars, and the dynamics of star formation. The telescope's high-resolution imaging and spectroscopic capabilities enable detailed studies of these objects, shedding light on their properties and interactions within their environments. The development and deployment of Webb represent a monumental achievement in human ingenuity and technological advancement. From its conception to its launch and ongoing operations, Webb embodies decades of collaboration and innovation among scientists, engineers, and technicians from around the world. Its success demonstrates the power of international cooperation in tackling complex scientific challenges and pushing the boundaries of human exploration. Looking forward, Webb's legacy will extend beyond its scientific discoveries. It will inspire future generations of scientists, engineers, and explorers to pursue careers in space exploration and astronomy. The lessons learned from Webb's construction, launch, and operational phases will inform the design and implementation of future space telescopes and missions, ensuring that humanity continues to push the frontier of knowledge and exploration. In conclusion, the James Webb Space Telescope represents a milestone in our quest to unravel the mysteries of the universe.